Before you go into introductions, I think the one question I like to ask everyone here is, what is the one thing that we should be paying attention to, and what is the one thing we're going to take away from this talk?
Yeah, I think that the one thing, the one big idea I really think everyone should walk away from with this is um, probably along the lines that the browser is the most natural in the age of web apps. The browser is the most natural um, system to use in order to shuffle data to and from other systems, particularly when it comes to LLMs. Uh, and that doesn't make sense at first, but when you see the kind of problems that we're facing, you slowly realize, hey, wait a second. This is a much nicer way of getting around some of the limitations of having to bring data to something like an LLM or an agent.
Got it. Got it. Great. Well, let's jump in.
Cool. Thank you. Um, so yeah, hi everyone. I'm Michael Struwig. I'm head of AI at OpenBB. And this talk, like we've just mentioned, is about how we approach RAG in a slightly different way for interesting reasons that you might not have thought of in the financial world. And yeah, it's kind of how do you do RAG, but without traditional APIs, where you have your agent that will actually end up hitting some kind of API to pull data in from an external service. We say we don't want to do that. Instead, why don't we just use the browser directly with our web application, OpenBB Workspace, in order to allow you to do things like connect data that is running on localhost, for example, to an agent that is running somewhere else. So yeah, let's jump right in. So who is OpenBB? We are a very interesting company and a very fun place to work. We have a whole bunch of different teams at OpenBB. I obviously run the AI team, and we have a couple of theses, I guess, or hypothesis that comes with what we think are the guiding principles for AI and what we wanted to achieve. So before we even talk about the product and what we do, we kind of really believe that human plus AI or human and AI is going to be a lot better than human or AI. Our vision of the future has got very little to do with AI actually replacing humans in day-to-day tasks. We see this much more as a collaborative kind of process. And for this reason, we've called our agents co-pilots historically. And for us, we really think that the symbiosis between human and AI, where the AI kind of makes a human better or offloads some of the tasks that a human would have to do, is going to be the future. The other thing that we have with our application is anything the human can do, the AI must be able to do, and vice versa. So for example, if the AI is able to retrieve a certain piece of data by generating certain input arguments to a widget that contains this information, the human needs to be able to do the same thing. We don't want the AI to be able to do something that provides an answer, but there's no way for the human to recreate the process. And we have the inverse as well. If a human is able to inspect some kind of data like a chart or manipulate the data in order to draw some kind of conclusion, the AI needs to be able to do the same thing. So we have this idea of one unified interface that allows humans to do everything, and the AI can kind of leverage that same interface. The other thing is that the data should flow freely into an AI system. So as you'll see in a second with OpenBB Workspace, we allow you to bring in your own data sources that you can then view and build dashboards from. And our philosophy is that, well, if I integrate the data, the agent should immediately have access to that data. There's none of this, I have to integrate it twice, or how do I get that data to flow into the agent so that I can, derive insights or query it or answer questions. We have one place, you bring in your data and you get the agent interaction for free. And we primarily target the financial industry. Although, as you'll see when I kind of talk about the product a bit more, this extends beyond that, but we're primarily focused on finance. So this is kind of what OpenBB Workspace looks like. Essentially, you have a series of dashboards. You have a whole bunch of different data sources. Here we have some news. We have a watch list for a various bunch of companies that we're taking a look at. We're looking at company news, maybe the price target. And on the right-hand side of the application, we have OpenBB Copilot. You can bring in your own agents as well, which is something we'll talk about in a second to explain how that works. And basically, it's just you can ask questions, get answers. We produce things like charts if you want as an output. And we also have full-blown citation. So in this case, we use the price targets widget over here that contains the data. And again, everything that the human can do, and we can manipulate input arguments, we can look at different kinds of data, we can do analysis, all of that the agent can do as well. And then you can pull all of this information, pull it out and create new widgets from it as well. So you have this kind of nice circular flow. It's a very organic research process. And all of these different widgets that you see, you can write your own and bring these in as custom backends, custom data backends, and do analysis in this way. And so this is kind of just to give you a sense of what OpenBB Workspace is about. It is a really, really amazing AI-driven analysis tool for predominantly financial data. But we kind of treat this as an extremely capable platform rather than just a product. So yes, you have multimodal inputs and outputs with the agents. So you can look at things like PDFs and CSVs and images and unstructured data like earnings transcripts and structured data like, historical stock prices over time. You can do all kinds of deep analysis using the agent on this. But where we really see value is that you can bring your own data. We see this with a lot of our kind of big enterprise customers. What they're interested in is they already have all their data. They're not looking for any kind of data provisioning. So they want a way to bring that in so they can analyze it in a lovely way. And now we've also recently launched the ability to write your own apps that run on OpenBB Workspace, which allows you to give a much more customizable kind of experience to your users. And of course, we allow you to bring your own agent as well. So you have a whole bunch of data sources that we kind of give to you out of the box, but we also have a way for you to bring in your own. And there's a whole bunch of apps. And this is a rapidly growing ecosystem where people are contributing the apps that they find useful. And then you just basically copy paste in a link and away you go. You have access to one of these apps that you can then use and do all of this analysis that you would typically do yourself in conjunction with an agent. But as all things go, there's a catch. And the catch is that we don't want to distribute your data. So if you're, building a crypto for a crypto custom backend that you now want to share with users and allow them to use, we don't want to be responsible for distributing your data. The reasons for this is it's really resource intensive. If you have a lot of data flowing through your system, it ends up costing a lot of money. The other thing that we're really cautious of, and something you have to be really careful of, is there's a lot of legal fuzziness around what counts as distribution. If you've purchased a data license somewhere, are you allowed to distribute it in this way? It's not always clear exactly how that works. And so we don't want to be kind of stepping on landmines, legal landmines here. And the other thing is that the data needs to be reachable over a network. So if I have my agent that we provide for you, how's it going to get access to that data? Well, it's going to have to be able to hit that API point directly. And that's not always the most feasible thing, especially if you think about big enterprises. So to take a note out of Raymond Hettinger's book, surely there must be a better way. And so the idea that we have at OpenBB and the way we build the workspace is we asked, why can't the browser itself be the data layer? So think about this for just a second. We have a local first web app. So the OpenBB workspace that I showed you, it predominantly runs locally on your machine, just in your browser. So the client code is distributed by the web, but the data doesn't actually flow through some backend server at all. It directly speaks to your browser running on your machine through the client code. The main benefit of this is we don't have to distribute your data, and you have really excellent security because you have to be on the same network as where the data is available. So if you think you're operating in some kind of cloud environment or some kind of on-prem situation, you can physically air gap a system to make sure that only when you're on this network will your app be able to have access to that data. And the bonus is that you can actually serve data from local hosts running on your machine, which is fantastic for development. You don't have to deploy this somewhere where it's reachable via some kind of URL or IP address. You don't have to worry about any of that. Everything just flows directly through your browser. And you have a bunch of really nice downstream effects of this. So how does all of this kind of piece together and work? So here you can basically take a look at our architecture, a very simplified version. But you have on your machine, you have OpenBB running in your browser, and you can have a custom data backend running on localhost that's connected to this. Or maybe you have a custom data backend that is connected or available via your network. And this is how the data essentially flows, right? We don't have some backend service that fetches the data and sends it through to you. This is all up to you. And the question is, well, if we want to connect an agent to this data, how do we do it? If this agent lives on some kind of external network somewhere like ours, how do we kind of get our data to have access to this? And the trick is, well, we're already treating the browser as a data layer. Why don't we just treat the browser as a crossroad, an intermediary, interconnect that can connect the agent to your data as well? And this is kind of the idea that we settled on and have really developed out, and it ends up being really useful. So you have client-side function execution for an agent that actually doesn't live locally on your machine at all. It might live somewhere else. Maybe it runs in your company's infrastructure. Maybe it's the one we host on our end. But we connect it to data that is available only on your local host or on your network. So the way this works is essentially you have a query request that the front-end application will make to our agent that specifies, the messages and also the widgets that are available that contain data, their descriptions, the parameters that can be set. If the agent decides it requires this information in order to answer the query that you have, it can submit a function call back to the front end that contains which widgets you want to have access to and also which input arguments to use. So for example, maybe I've got the widget set to, Tesla, but I want to query the earnings transcripts for Apple. We allow the agent to kind of change that. And then you have this little function calling handler that actually runs in your browser locally. And what this does is this can then go and interpret this function call, execute it and fetch the data, and then respond with a follow-up query that contains both your messages and the result back to the agent. And so basically you've just used what we call the agent protocol as a way of connecting an agent to data via the browser, via something that's running locally. And this agent protocol is what basically allows us to work. And I'd like to talk about this a little bit now. But I guess before I do, the downstream effects of this approach are really big, because take a look here. If you only integrate your data once into OpenBB Workspace, but once you've done that, the agent itself doesn't have to know anything about how to access this data. It has to do something really, really simple. It has a unified interface. It just has to specify the widget UUID and the input arguments that it wants. You can choose not to generate input arguments if you don't want to. You can just reuse the ones that are currently set. But the point is, you now have this nice separation of concerns where you integrate the data once, and your data is now instantly available to either our agent if you want to use ours, or your agent if you want to use yours, no matter where it's running, whether it's on your machine or not. And so when we were designing this agent protocol, we cared about a couple of really important things to us. It has to be easy to debug, easy to test, easy to reason about. This is really important if we want people to build their own custom agents. If we want to make our lives easier for ourselves, it has to be something that is easy to understand, easy to make sense of. We want to use standards that people are already familiar with. So we're not going to roll out some kind of new protocol that nobody understands how it works. Sorry, MCP. And we also want to try, we don't want to be clever. Engineers tend to get themselves into a lot of trouble when they try and be clever. So we want to have something be as, boneheaded, simple as possible. And so basically the resulting API is stateless. So your agent or our agent doesn't have to handle any state at all. It's all handled by OpenBB Workspace. So this is fantastic for debugging, for reasoning about your problem. It's easy to do unit tests because you just have to hit it with with a payload and it will do the right thing. It is reproducible, which is a really big deal. It doesn't require a lot of storage as a result. It just makes everything easy when you don't have to worry about state. It also uses REST, so post, get, request, that kind of thing, which is familiar to everyone. Everyone who does any kind of web app development will be very familiar with REST APIs. And it uses service-sent events, which have become the standards for communicating with LLMs. And the other thing is that, like, we published this protocol. So we have, it's available here on GitHub. It's called the OpenBB Custom Agent SDK. But basically, the entire protocol is available. It's pip installable. We just made this public yesterday, although it's been on PyPy for a couple of weeks. And this is what we actually use for our OpenBB Copilot as well. And we just say to everyone, hey, just use it. Build your own agent. We support it. And so all of the inputs, the outputs, and the models and stuff like that is available here for the protocol for free for you to take a look at and to use. And what's lovely about it is it's actually really simple. It's got a couple of very minimal primitives that allow you to do all of the important stuff that you care about. So, for example, if you want to stream strings message chunks back to the front end, you just, from an execution loop, you just yield message chunks. If you want to yield reasoning steps, so we actually allow you to provide these little status updates, kind of like what ChatGPT or Claude will do if they're searching the web. It kind of gives you information about what's doing next, which widgets we're accessing, what kind of queries we're making. That's also just a single yield away. You just yield the reasoning step. If you want to fetch widget data from OpenBB Workspace from the front end, well, it's just, you just yield this. We specify the widgets and the input arguments that you want. Same with producing citations. Maybe you want to return a table, or like the screenshot that I had earlier, you want to yield a chart, and you can do, pie charts, line charts, bar charts, scatter charts, whatever you're interested in. It's all these really simple kind of building blocks that you just figure out what your outputs need to be, and you just do them, and there you go. So this is what it looks like. If you have a existing agent and you want to make it OpenBB compatible, because of this protocol that we have, you basically just need to accept this request payload as an input into your endpoint. And you just, inside of your execution loop, you need to stream back SSEs and you just yield from this execution loop. Simple as that. And all of this code, we have examples that show you how this works. It's available if you want, just go on GitHub and just search for OpenBB and you'll find all of our stuff. And yeah, if you want to fetch widget data, it's literally just as simple as yielding the right request, and we'll take care of everything else for you. So we kind of have two types of functions. You have locally executed functions, which is what you're probably used to. This is where the function is executed in the same environment or logical space, computer, if you will, where the function is called. This is what everyone's used to. But now we kind of have this idea of a remotely executed function, which we use to fetch data from the browser, where we actually have a little mini interpreter that runs in the browser that can execute these function calls. Because nobody said anything about where the function call needs to be executed. And so this is how we ended up solving this problem. And the separation of concerns is actually really nice, like I alluded to earlier, because you basically don't have to worry about having your agents understand how to call data. Your data team and your agent team can actually work completely separately, because we have this guarantee that if you bring in your data onto OpenBB Workspace once so that it's human readable, it immediately becomes AI readable. And so the separation concerns makes building agents and integrating data into them so much easier, because the only thing you care about essentially is what's coming in and what you need to send out. So it's super unopinionated, because it's just a protocol that you have to yield events from. It works with any AI system, whether you're using, God forbid, Langchain and stuff like that. But let's say you're using Langchain or OpenAI's SDK directly, or Anthropic's SDK directly, or Google Gen AI's SDK directly, it will work with all of these, because you just need to yield the right events. You need to format the messages and yield the right events. The agents don't need to manage any of the state. They They don't need to understand how APIs for the various data sources work. They only need to understand how to pass the requests and yield the function calls when they do that. So it's just a single kind of yield statement away. And it's easy to make your existing agent compatible. And so basically the big takeaway is, well, treat the browser as this super nice universal data protocol that you can bring your data into without it having to flow through some kind of backend, and then just do the same thing with your agents as well. And so, yeah, that's kind of the short and sweet of it. So we're OpenBB. If you want to get in touch with what we're doing and stuff like that, feel free to, send us an email. We have a generous free tier, including the AI, so feel free to try it out. And, we're not restricting you. You can bring your own data, your own apps, your own agents. And yeah, we have all the compliance and things that we need for enterprise-ready deployment too. So that's it. So thank you very much. And I think now would be a good time for folks to ask questions. We can have a discussion. And I'm more than happy to answer any other random questions, Jason, that you have as well.
Sounds good. Sounds good. I guess the way that I feel about this right now, it kind of feels like what MCP has been trying to do to some smaller extent. It feels like it's actually way less scope than what the protocol is doing. And a lot of it is actually building around like the browser versus the client and like some widget UI. But could you just add a little bit more color, especially because I think our MCP came out maybe around like the same. I mean, what is the AI timeline really? But around the same time.
Yeah, so we ended up building this. We ended up building this long before MCP was even an idea, and before Anthropic even published their blog post where they announced MCP and that they were giving this away for free. So this predates that. You're right that it's a lot simpler. The problem, and we've considered like, can we use MCP for this? The problem with MCP is there is a baked-in assumption. It's a little bit subtle, but there is a baked-in assumption that the function call will be executed by the MCP server. And so that implies that the data that you need to have access to needs to be accessible by the MCP server. So if your MCP server is running on your local machine, that's fine, because you might be able to have access to the data that you want to share. But if that MCP server is being hosted by us and we just want you to plug our agent in, you won't be able to access data that's flowing through, like that lives on your local host. And so for us, that was like really important, is making sure that you can only access the data when you're on the right network and via or on the same machine. And so MCP doesn't solve that problem, although it solves a bunch of other problems.
I see. It sounds like a lot of this is actually around governance and access controls and sort of the things that are important for OpenBB, which I think is also probably a pretty good segue to the other question, which is, how do you avoid mixing like confidential data that your users might bring in with other public data around these workflows? What kind of like tools have you had to build to overcome those?
So for us, we pretty much solve this in the enterprise sense. The way in which we solve this is we basically deploy stuff on-prem and we give them a proper air-gapped system. So the only data that's coming in will be data that is working on their network, where they have things firewalled away in a VPC. So that's one way in which you can solve the problem. And besides that, we don't actually distribute any of the data. So it is entirely up to you to decide how that uses. So because everything flows through a local browser app that's running in your browser, it's completely up to you what you choose to bring in. So we just say, look, here's the platform. It's just a platform. If you're going to be silly and publish your custom backing for people to use publicly, like that's on you. So don't do that. But if you wanted to misbehave, I suppose you could. But we obviously just say, look, just stick it in the workspace, and then you're responsible for how you choose to distribute your data.
Makes sense. I'll save the Langchain question for later, but something about as well, which is, could you share a little bit more about your evals pipeline? How do you validate whether the user query is being used appropriately by the agent and executed in the right way?
So this is a really good question. So first of all, what makes evaluation extremely hard for us in particular is when you're doing something like financial analysis, it's very hard to validate whether the answer is correct or incorrect. This isn't like generating code where you have a unit test that the generated code needs to satisfy. And that's something that would make this process a lot easier when you have very non-specific answers. So for example, what do you think the possible outcomes could be for a company based on this and this and this data? It's not easy to rate that. So for us, we do, in terms of answers, we actually rely on our users to give a thumbs up and a thumbs down. It's not the best solution in the world. The reason being you only typically get responses from about 1% of users. So what we do is we take at least if you're scared of hallucinations, what we do is we say, well, it's going to be hard to control that. So we take a radical observability approach. So every piece of data that the agent interacts with, produces an answer with, fetches, summarizes, queries, whatever it is, we have a full citation trace that we return with every single answer. So you can see exactly which input arguments were used, which widget it was. We highlight the specific widget. If it isn't on the dashboard, you can click a button. We can add it to the dashboard for you with the input arguments that were used. So for the human, we make it as easy as possible to actually observe and analyze and make sure that things are correct from that point of view. For us, what we really spend a lot of time doing is we sit with users and we chat with them and we do vibe checks, which a lot of people say, oh, so you're just relying on vibe checks. You know what? Vibe checks are surprisingly high information. And you can often tell a lot more by taking a look at what the agent saw and the answer provided and fix things that way when you see things going wrong. Sometimes you just have to hop in and actually take a look at those traces. And we spend a lot of time doing that.
Makes sense. I guess on that line of like these citation traces, like what kind of tooling have you been using? I think a lot of people have questions and thoughts on like vendors, for example, but like what kind of toolings have you enjoyed working with?
So for us, citation wise, and to handle all the data that's coming in and coming out, it's a custom system that we wrote. No one is really that great at doing citations. And obviously, because we control the data plane, we need to be able to map back to that somehow. So we have to do something custom. In terms of monitoring, we currently, the only really off-the-shelf tool that we use is two libraries that we really like. The one is by Jack Collins. It's called Magentic, Magentic. I think it's the nicest LLM framework that's out there. It's very minimal. It's a shallow wrapper over these. It allows you to control how things get executed. I think it's the right abstraction for how LLMs work. So I recommend people check it out. It's full of great ideas. And then we use Logfire to do our tracing, just because it's really fast. It has a nice user interface and it's open telemetry compatible, which if you care about telemetry, you'll understand why that's like a really important deal and why it's important to have.
Yeah. I'll also just make a plug, which is that if you're part of the students of the course, then I think Logfire, we have like a $500 promotion with Logfire. Little plug there.
Nice.
If any of these people want to try these things out. Yeah, that makes a lot of sense. I think open telemetry as a standard is really, really valuable, which kind of brings me to maybe the next question is like, what were your experience with like Langchain? Sort of like, why was it the God forbid?
So I like poking fun at Langchain. Look, I think I started at Langchain. I think most people did. The gift that Langchain, I think, gave to developers around the world is this idea of it's not just a one and done request for a completion to an LLM. You can actually chain these things together and you can get quite interesting behavior from it. I think that is a really significant popularization of an idea. The problem, not problem, I guess the critique I have of Langchain is the same one most people have when you've tried to work with it, which is it's heavily abstracted. It makes a lot of strong assumptions about how your business logic should work. And it ends up solving the average of a lot of problems. And the issue with solving the average of a lot of problems is if this is my problem and this is my problem and this is someone else's problem, the average is right here, which means you solve no one's problem. And so Langchain is great for your hello world example. But the second you want to do something just a little bit custom, like maybe I just want to do this one intermediate step before I submit my completion, it makes it really hard to do that. And almost invariably, you end up reaching for the base SDK or something that just gives you a little bit more control over how the agent will execute things. And that's kind of been my experience. It's been the experience with everyone I've spoken to that's decided to really go heavy in on building this stuff. You end up just going, "Ah, man, like this, I'm fighting this framework now and I can't figure out how to customize it. I'm just going to go for something a bit more, more custom."
What kinds of abstractions or architecture have you sort of adopted? I think one of the questions that just came up was, I think Llama Index is now trying to do this like event-driven architecture, and LangGraph is state-driven workflow. What has felt right for the kind of products that you've been building? Or the for loop and completions call?
Yeah, I actually think the abstraction for us that we also ended up doing really early was like the state machine model. So the idea is you have one main execution loop. The model decides what to do, and that drops you down into another sub module. So for example, let's talk about how we do analysis of something like a PDF, right? So if you're doing analysis of a PDF and you bring that data in, our model will then say, oh, okay, this is a PDF and we need to, I don't know, summarize it. That then is a function call that then drops into a sub module or a sub agent that has its own mini execution loop. And then that then has all of the functions that it requires in order to analyze and assess a PDF. And what you can do is you can yield these events to the upper loop that then yields it to the client. So basically you can go deep and bubble things up, and that's how you can get things like status updates or citations or intermediate responses and stuff like that. We just bubble everything through the execution loops. But the right way to think about it is a state machine with various states, and each of those states themselves is a mini state machine. And that seems to work extremely well. And it's easy to reason about as well.
Okay, this makes sense. There's a lot of really great questions coming up. I'll do one more question from the upvotes, and then we'll also do some live questions as well. So if you see the react, you can basically use the hand raise gesture, and then we can go from there. Yeah, and as people are figuring that out, let's ask some more questions.
Sure.
This is like this very simple one. What did BB stand for in OpenBB, and what is the USP of OpenBB?
So yeah, the BB, everyone thinks it stands for Bloomberg, but it doesn't stand for Bloomberg. It actually stands for BlackBerry. So the origin of the company is really, really interesting. So Didier, the founder, he essentially wrote a financial data terminal that ran in your CLI, like in your terminal, that aggregated a whole bunch of financial data. And this happened during the whole GameStonk GME event that happened. And Didier threw it on the Wall Street Bets subreddit, and it blew up and got a crazy number of stars. And that's kind of the origin behind that. And then when they created the company, as far as the rumor goes, him and his co-founder James, they took like a crazy wild bet on BlackBerry that didn't pan out, and that became an inside joke for them, and so they decided to call it OpenBB.
Beautiful. That's pretty funny. I didn't actually know the Wall Street Bets history.
Yeah.
Are there any readings you would recommend on this like state machine approach? There's a follow-up question that I don't fully understand what this means, but by state machines, do you mean like Moore or Mealy machines? I don't know if you're familiar with those terms, but just generally readings on the state machine kind of model.
Yeah, so I'm not familiar with those terms. I guess I'll just explain what I mean, because it's the way I interpret it. But basically, the idea is it's kind of like agentic RAG, where you have the agent generate the search terms, let's say, for data. But rather than doing that just to fetch data, you essentially have all of these sub agents that have their own execution flows that you can drop into via function call. So if you have your main execution loop, which is where the agent is essentially sitting, you can imagine the agent sitting, and it's got maybe some context of what data is available, and it has a whole bunch of tools that it can choose from. And it essentially says, okay, I want to use this piece of data with that tool. And then that becomes the state that you then enter and then analyze the information that way. And then you just basically hop between these. So you go and execute something and then bounce back up to the main kind of, okay, what's my next decision that I have to make? And in terms of like reading material, I don't think I would read too deeply in it. You could probably Google some stuff. Just go build it. Go build it. Figure out. I'm gonna connect two agents together. One agent that comes up with the plan and another agent that executes the plan. And just bind the two of them via function call. And pretty much there you go. You've got two states that you're playing with.
Got it. Deep has a question. Any kinds of challenges that you would like other sort of like support on, or kind of problems that are very open for you?
It's getting better now. Um, so, and I think Google and Gemini are doing the right thing, and I've seen OpenAI start doing this too, which is a lot of the stuff that everyone wants to do, which is a bit tricky to handle. So, for example, code execution. Doing code execution yourself, we've done it. We had internal tests of it. Is quite a tricky thing to do because you have to spin up a remote REPL. You need to be able to submit instructions. You need to manage state, that kind of thing. What Gemini does, which is really like, I'm glad they did it and I'm glad other people are following them, is that just becomes something that you can toggle on, and then their agent will handle all of that. It's abstracted away from you because handling that is not really the problem you want to solve, but it's a big pain. So to have all of that kind of stuff happen for you is really nice. So like Google also integrating Google Search into their stuff, which is a common use case. That's really nice as well. Let me think. What else is you see the problem is I have the curse of knowledge, which means I've gotten so used to the stochasticity of these models and kind of constraining down, because fundamentally, what are you when you're programming with LLMs, right? You're prompting these things is you're shaping probability distributions in order to have them model as reliably as possible, take the actions and pathways that you want. So you're painting these probability distributions using words and using tools and stuff like that. So that's fundamental. And I'm so used to that now that it's kind of hard to think of it in any other way. Um, hmm.
Let me ask a question real quick. Have you used things like E2B? I know, like, I think in this case, if you
Yeah.
do Gemini, you're kind of locked in a little bit more, but I've not really tried much of it myself, but I'm curious, like, if you use something like E2B where they do their own like code sandboxes and
So we looked at it. They weren't SOC 2 compliant, which is an issue. So we rolled our own. So basically what, this is just a fun aside. So basically with, over like a weekend, I ended up writing a mini interpreter in Python that would take in code submitted as a string by the LLM, do abstract syntax tree parsing, evaluate that code, capture the outputs of that, and then return that. So essentially, we emulated a REPL that would run on like AWS Lambda with state, and it was kind of like a fun hackathon project. And that worked. Like it worked surprisingly well, and it was super cool. So that's how we did it, so we can make sure it was SOC 2 compliant for people who were potentially using it. We just then ended up changing directions because people really showed interest in building their own agents. So we never really released that to the public. Maybe it's gonna come back. We don't know. But yeah, it's not that hard to roll it yourself. You can probably vibe code it if you want, and that's something that's quite fun to do. Python's amazing. Interpreted languages are fun because you can do this kind of thing, right? You don't have to compile them first.
Like it's not SOC 2 compliant, but I'll just execute the string.
Yeah. Yeah. And it's fine because if you run it on a Lambda and it's isolated and sandboxed and you have a execution time limit, can't do anything. So you're fine in that regard.
It sounds like there's not many live questions here, because I'll sort of use the question I ask everyone at the end, which is there a question you feel like folks should be asking? Whether it's about like multiple tool use, whether it's like building out these platforms, I think
I think what people should be asking, and whether I'm not seen, I've seen a little bit of talk about it, but not enough. When will locally running language models be integrated into browsers? Um, and when will a web standard be published that allows web apps and websites to interact with those language models running in your browser in a native way? Um, I think I think longer term, this is what we're going to see. Like the browser is by far the most important application on a computer. Um, and it just seems like such a natural place to want to slot in an on-edge LLM is like something that like, Google played around with having an LLM running in Chrome. Um, but I think that that interface to allow a web app to use that to maybe provide some kind of LLM powered experience that's running locally on your machine that interacts with that, like maybe like a type checker, or maybe something that can allow you to hide content you don't want to see or do translation or whatnot. Um, I think that is going to be. I would make a bet that that is going to become a web standard at some point. And as we get better at distilling these models, as we get better at running them more efficiently, I really think that we're going to start seeing these things embedded directly into browsers, which is where the users are. The web is the operating system of the world right now, and I think a lot of more people should be asking, how can we make these LLMs that run on the edge, how can we make them more efficient? How can we make them more accessible to normal people? How can we distribute them easily? Um, and the answer to that is, well, you're going to have to use the web browser, because my grandmother is not going to install Olama, right? But she sure as hell knows how to browse the internet with Chrome. And so I think that is going to become the natural target for where LLMs will eventually be directly integrated into.
Yeah. I think I'm gonna ask the question here. Like, do you think it'll be local first on desktop or mobile first?
Mobile, almost certainly mobile.
Yeah, I feel like I saw Jordan Singer who recently has been doing a lot of like LLM local on mobile devices that have been pretty running pretty smoothly. But we'll see. Maybe it'll just be mostly a hardware limitation. Um,
Yeah, that's the problem right now. But I think because more people have phones, it'll be the natural target, particularly in the developing world. I think that's a. I don't know how you monetize this stuff. I think that's the big problem that all the big tech giants are still trying to figure out, is like, how do we monetize this in a way that is sustainable and that warrants us investing, energy and time into this. But I suspect they'll figure it out somehow.
mhm. um, and then maybe we'll leave off with this question from Deep, which is how do you make your agents sort of self-improving, right? When they have errors, they would make mistakes. Like, what is the flywheel that you've spun up to allow these models to sort of learn from these mistakes?
Uh, easiest one, the easiest one and the most obvious one, right? If you run into some kind of error, if the agent isn't able to do something correctly, have really good error messages and just, return those and then let the model try again. You see this everywhere with any kind of agent. Uh, that is typically the thing that you can do. The other thing is keep really good logs of all the ways in which things go wrong. Typically, you'll see there's a couple of key patterns that emerge where a model is always making a stupid mistake. Like we noticed, for example, one of our agents, always for a particular data source, it always generated input arguments, even if you asked it not to. And we noticed this pattern in our error logs. We aggregate these and we look at like trends of errors, and we notice, we didn't allow it to optionally specify certain input arguments, right? And that's just like a common failure mode that we saw everywhere. And the second you see that, you realize, oh, okay, I'm asking the LLM to do something that's impossible for it to do. And then you fix the system. Don't try and prompt it differently if you can help it. Just try and change the problem that you present in a way that makes it less possible to get wrong, preferably with like some kind of hard coding solution that you can do. Um, and we found that more effective than trying to build some kind of self-improving system. We're the self-improvers in this case.
Okay, this makes sense. It's almost like we want to primarily just like improve error messages, and then you're doing a lot of this like data aggregation of the error messages or the failure modes.
Yeah.
Because like, what does that process look like? Is it the case that we just have like messages on Slack? Is there some dashboard you're looking at? Is there some, you know, every other week we get together for 40 minutes. We scroll through like Logfire. We kind of just hypothesize what are the next big issues that are coming up.
Yeah, our process is really primitive, but you know, it's not stupid if it works. We look at the we look at the logs. You know, we have a couple thousand questions a day. We look at the errors that come up through those. Sometimes we pipe those to a Slack channel so that we get notified of them. But we just keep our eyes open and we pay attention to how people are using our product, and where things are going wrong, where things are going right. And based on that, it's often easier to just by looking. It's not this massive fire hose. Just by looking where things go wrong, you very quickly identify common failure modes. And I think rather than trying to build like some kind of specialized tooling to do this, getting something that just dumps a message in Slack, or just having people every morning when you wake up, hey, what happened last night, or the day before in terms of what went wrong? Just go look, and often you notice things that you can immediately fix. And somehow I think we just don't flex that muscle enough. Really, it's really that simple in many ways.
Yeah, I saw Mohammed ask, like, do you use an LLM to summarize the logs? It's almost like
Nope.
it's better to just look.
Yeah, we just look. It's astounding how just like looking at logs, and obviously this assumes you have decent logs to begin with, but we don't do any crazy smart stuff. Like, we're a small team. We want to move fast and we want our systems to be reliable. No, we just go look.
That makes sense. I think, every time I'm working with another client, they're like, oh, we just want like more reasoning. Like, we just had more reasoning. It's like if you're delegating all the reasoning, what's your job, right?
Yeah,
You
yeah,
if you
exactly.
do enough reasoning, then you can use the simple processes. I think too many people are sort of now too lazy to stare at things, which has been
Yeah, I mean, look, like one of our neighboring countries is Namibia, and the story will make sense in a second. And it's a really rough place. It's absolutely massive. There's only 2 million people there. It's one of the remotest countries in the world with some of the harshest terrain. Toyota, who builds a lot of vehicles and stuff, they send their execs down with cars to Namibia to just watch what breaks. That is surprisingly effective. You don't need workflows. You don't need crazy tooling. Sometimes just putting your boots on the ground and looking at what's going wrong, that's the highest information signal you can get.
yeah, totally, totally. It's just you know walk the assembly line. I think is something people are not doing enough now because
Correct.
like the assembly line is made of robots. We have the robots looking at the robots, looking at the robots, and then when something breaks, you sort of have these big questions. Um,
Yeah, exactly. Yeah.
let's do one question before we go. Kasim says, in these workflows, like how do you think about or manage expectations around latency or just sort of latency?
Brilliant question. Okay, so fantastic question. This is where these status updates come in handy. Hold on, I'll go back to here. So, okay, it's hidden a little bit, but you see the step-by-step reasoning? If you expand this, it's got a whole bunch of different steps that the model took in order to produce this graph, right? It went and queried the right widget, it fetched the data, it then decided to produce some intermediate queries and then produce the chart, right? One of the things you don't want to have a user do is sit there wondering what's happening. It's why OpenAI will show you the thinking of a model if it's going to be doing some kind of reasoning or whether it's searching the web. You need to have some kind of user feedback because users want to look at stuff. And so this is why they started streaming back tokens. One of the benefits of an autoaggressive model is when you've got a token, you've got a token. And the other thing is, well, we make it really easy to understand exactly what the model is doing. So, hey, I'm busy querying this widget with these input arguments, and here's why. Now I'm busy writing the SQL query in order to analyze this structured data. This didn't work. I'm going to try this now. Okay, I've got the answer now. So it's kind of like just providing that constant user feedback. That's the one thing that's really important. And the other is often you'll find when you're querying multiple pieces of data, if they don't need to interact with each other, it's an embarrassingly parallel problem. So you just split off the path and you do everything in parallel. And you combine things together. So if you're summarizing 10 PDFs, there's no reason to have to do that sequentially. You just say, hey, I'm going to summarize the 10 PDFs. You split them up, you summarize them, and you combine the answer at the end. And so that's the way you kind of manage latency. And ever since we've been doing that, users don't seem to complain. you can only read so fast anyway.
Yeah, I feel like Cloud Code has recently made a lot of really nice changes to just make the labeling feel very good. There's always something moving on the page. Tickle the brain.
Yeah, we're simple creatures.
Perfect. All right. I think this was great. I mean, I feel like I have a better understanding of some like it's funny because a lot of the things I think about in terms of improving systems are about like retrieving few-shot examples and having like better prompts for, messaging. But yeah, I feel like I've actually gotten that a good error message is sometimes the most important thing.
Good enough.
Really, and maybe this is just a function of the models being good enough to really be able to parse these. But it seems like just investing in better error messages is something that is worth. It is effectively an investment in the like execution harness of the system that you're building.
Yeah. Yes. I mean, look, what are these things trained on? They're trained on tons of human data, right? It kind of makes sense that if your error message will not be informative to a human, it's not going to give you a probability distribution that will lead to a good answer or a good next step by an LLM. So what's good for the human is typically good for the LLM as well. And sometimes I think anthropomorphizing LLMs more is a good thing, not a bad thing, for exactly that reason.
That's a good takeaway. Well, I think we're at time. Thank you so much. Is there any other parting words before we go? We will send the notes to everybody via email, but yeah, if we can share the slides as well, just let us know and we can make sure to do that.
Yeah. Yeah, 100%. Yeah, feel free to share the slides. I'll make it available to you guys. Yeah, give us a try. Send us an email. Bring your own agents to OpenBB. It's a lot of fun. And yeah, thank you so much for having me. It was really great. And at the moment, no, but maybe see. So we'll see.
We'll keep everyone updated. All right. Thank you, Michael.
Perfect. All right. Cheers, everyone. Thank you.
Take care. Bye-bye.